Hello everyone, welcome to this year's first Blender presentation here at FMX 2014. My name is Thomas Dinges and I'm one of the Blender and Blender Cycles developers since 2009. And today I'd like to give you an overview of our render engine, talk a bit about the things that we worked on in the past year, show a nice new demo reel that we collected in the past 2 weeks, and give you a live demo afterwards on this great workstation from Cut Network here. Okay, so I guess everyone heard of Blender. So is there anyone here who is not a Blender user yet? Maybe just quickly raise your hand. Okay, 1, 2, 3, okay. So just very briefly in 2 or 3 sentences, Blender is an open source 3D package which can be used for creating images and animations and VFX. And Blender can be used for the entire pipeline, so we have tools from modeling through animation, shading, lighting, rendering, up to compositing, and even some video editing. And we had a Blender internal render engine since Blender started 20 years ago or so. But a few years ago, we tried to refactor that engine and improve it and bring it up to something that is more in line with today's needs and today's expectations. But it was not really doable, and so Brecht von Lommel, the main developer of Cycles, decided to start a new render engine early in 2011, and that's when Cycles was born. And with Cycles we try to bring a new render engine to Blender, and it has been in development for the past 3 years already. It is integrated in Blender since end of 2011 now, and can be used for a lot of great things already, and that's the topic of my presentation today. So Cycles is meant to be a production renderer for smaller studios. That means that of course you can use it as an individual if you're a freelancer or so and you want to do 3D artwork, but we mainly target the smaller teams and smaller studios. And that has several reasons. One of them is that there are a lot of render engines out there already that fit into a certain paradigm, and they do a lot of great things and images. But you have a lot of render engines out there that are really physically accurate and produce really high-end graphics. But on the other hand, you also have render engines, that are more a bit into the programmable, which are more programmable. So like RenderMan, for example, with the RenderMan shading language. And with Cycles, we try to combine those two main aspects of render engines. So on the one hand, Cycles is a physically accurate and physically based renderer. On the other hand, we allow our users to be really creative and to have a great process and get crazy with it. So we have full support for open shading language, for example, which is a powerful shading system which you can use to write your own shaders to express your creativity. And that's what Cycles is all about. It's about the artist, and we are committed to make that available for everyone. And Cycles is not only usable inside of Blender. I will quickly demo that later on and talk a bit about some things that we worked on in the past few months to make Cycles a truly standalone render engine that can then also be integrated into other 3D packages, for example. Our focus is also on interactivity and ease of use. So we want that the artists don't bother really with settings or stuff like that. So we only want that you guys just open your scene, set up some materials, and you are good to go. And one thing about Cycles is that it is also released as free software under the Apache 2.0 license. Blender itself is GPL software, that is also free software. But with Cycles, which is again a standalone code at first, we wanted to make it even more open. So we decided to relicense it last year, 2013, under Apache 2.0, which is the same license as some libraries use, for example, OpenSubdiv from Pixar. And that allows people to have a really, really open approach, and you can integrate Cycles even into commercial applications, link with commercial code, and you can basically do whatever you want with it. So there is really no limitation here. So I want to quickly talk a bit about what we have in Cycles, what features we have, and what you will find there. So first of all, cycles can be used to render on both CPU and GPU. We are not a hybrid engine, so we don't do the ray intersection on the GPU and the shading on the CPU, for example, but we do a unified approach. So we either render on the CPU or on the GPU, and everything that you see, everything that is being calculated runs on CPU or GPU. And we use path tracing, unidirectional path tracing to be exact, which allows for a great workflow. So you can have instant feedback when you render in your 3D viewport, for example. You get immediate results, and then for the final image, you just keep it rendering for a while, and then you get a nice, clean final image. So that is a nice thing if you are working in the lighting department or you do shading and you want to get immediate feedback about your scene and what you're doing. And we are also unbiased, which means that we try to avoid tricks where possible. So we want to really have a physically accurate render engine which delivers great imagery without making compromises. Although, of course, you can use tricks to make it faster and also be a bit more creative, like going a bit into the toon rendering or non-photorealistic rendering. But mainly we try to avoid those kind of things and just have a great render engine that produces real imagery. Our node system is physically and node based, and we have full support for open shading language. For those of you who have not heard about OSL yet, OSL is a shading system that has been originally written by Sony Pictures Imageworks, and they use it in combination with an in-house version of the Arnold renderer at Sony Pictures. And outside of Sony Pictures, there are some render engines already that have OSL, like V-Ray has it now since half a year or so, and Autodesk Beast also has some support for it. But we are really the most powerful render engine on the public market with OSL support. So in terms of OSL, we support the full range of OSL features. You can create surface shaders with it, you can create volume shaders with it, which is a truly amazing thing here. I will show you that later. And we are the only OSL capable render engine with volume shader support. There is no other render engine out there that is available to the public. So unless you don't work at Sony Pictures, you cannot use that technology so far. And that is something that is really nice about Cycles. You have all the great technology here at your for you to use. We also support very advanced features for participating media, for example, volume rendering. So we have volume absorption, scattering, and emission. Also smoke and fire rendering that was added recently. And we also have a ray-traced subsurface scattering algorithm. And the great thing about that one is that it delivers really great imagery. You can tweak it easily. And we don't use pre-passes here, so we don't use light caches or pre-passes to calculate that, so you immediately see the subsurface scattering. And the algorithm is also at the moment being ported onto GPU, so you will be able to use that on the GPU later on as well. We already made some tests with that. So if I quickly go back to my first slide here, that image here, that is a caterpillar, and he was rendered on CPU and GPU. So about half of the frames of this animation, I will show you that animation later, has been rendered on GPU with the full subsurface scattering algorithm, and the other half on the CPU. So that is technology that is already available today on whatever hardware you're using. And of course we have other things that you need for a production renderer. We have full support for motion blur, so whether it's camera motion blur or transformation, deformation motion blur. We have depth of field directly in the render engine. We have instancing support, so you can just have high poly models and duplicate them across the scene and have a low memory footprint at the same time. We have various camera models, so you can use a perspective camera, an orthographic one. We have a panoramic camera with fisheye support and everything. A lot of procedural textures, image textures, and image-based lighting for the world background. And we also have great tools for compositing artists, so you can use render layers and render passes to tweak that the render result later on in your pipeline. Okay, but now it's time for a demo reel, which we assembled in the past 2 weeks, and that should give you a smart glimpse of Cycles' capabilities and some productions that it has been used on so far. Okay, so that was a short demo reel, so you get an idea about the engine. What we've had here, we had commercial projects which were just commercials, advertisement things. We had animation projects, we had VFX elements combined with real footage, so we had a full bandwidth here of productions. Okay, let's talk a bit about the main features that we've added since last year's FMX. So the main two things that we added since last year is volume rendering. We had initial support for that in about December last year, and recently we added support for voxel rendering, so you can do smoke and fire and everything. And we also added deformation motion blur, which is important for when you have characters that are animated and you need motion blur on them while they're moving. And the other thing that we really focused on is performance. So I'm not lying to you guys. If you watched the reel closely, you saw some noise in some scenes still. That is a problem that we had, especially last year when Cycles was not so well optimized yet, but we are really working hard at the moment on performance. And maybe you've seen the Caminandes short. I will play back that in a few minutes as well. That short film has been created by the Blender Institute in October last year, and we could basically halve their render time since then. So we made a lot of improvements for transparent shadows, which is very important when you have things like transparent hair or trees, for example, with leaves and alpha textures and everything. So we made a lot of performance improvements there. We improved the hair rendering system, so it's faster and better. We improved the ray tracing itself, so the ray intersection, so when you have like a dense geometry or so, you will get faster rendering now. We improved texturing and also made some enhancements on the GPU. So in total, there are some scenes that render like 3 or 4 times faster now compared to the render times we had like half a year or 1 year ago. So a lot of things improved there. And that is also the focus really for this year. So now that we are almost feature complete, we are focusing on making everything better and everything faster. So the main topic this year will be performance and memory optimizations, so you can get bigger scenes and render them in less time. Another big thing that we will still be working on is displacement support. That wasn't really a priority for us so far because Cycles is integrated into Blender, of course, and you have subdivision and displacement in Blender itself. So it was not really a priority to have it in the render engine, but we will also implement it into Cycles so we then can benefit from some other things and also lower the memory consumption there. Another thing that has been worked on in the past few weeks by a developer, that is texture baking. So that is very interesting for people who want to, for example, just bake the global illumination into textures, to use it during the rendering then to lower the render time, but also for people who want to use it in external engines or game engines, for example. So you can use Cycles to bake global illumination and then save that as textures and use it in other programs or game engines in the real time branch then. And also one thing that we might add this year is subdivision with OpenSubdiv, the library from Pixar. At the moment, one developer, Sergey Sharebin, he is working on OpenSubdiv integration in Blender, so that is being worked on at the moment. But we also want to have it in Cycles itself at a later point. So maybe we will get to that as well this year. And there are some other experimental features which are in development by other developers at the moment. So one of them is network rendering. So I don't know, but sometimes it's a bit of a problem to render things on a render farm, because you have to make sure that your textures are available on a shared drive and all your computers can access that. And with Cycles, we try a new approach here in Blender. So we also want to have a system where you just have your client, you start your scene, and then it automatically distributes the scene onto several render nodes. And those render nodes then will be used for the actual rendering. So Cut Network here, for example, they also sell some great render cubes you can use with Intel Xeon processors, and then you can use them and distribute the tiles onto them, and then they do the actual rendering while you can keep working on your scene on your main workstation. The other two things that we are working on is Metropolis Light Transport, MLT, which is an improved algorithm of path tracing, which is really beneficial in scenes where you have like caustics, for example. So you have like an ocean or swimming pool or so, and you get nice caustic light effects and stuff like that. So that will improve the convergence of these scenes dramatically. And we also work on adaptive sampling. So at the moment, samples every pixel with the amount of samples you set. So when you have like 100 samples, it will shoot 100 samples into each pixel, and then we want to make it a bit smarter. And when we have like parts of the image where it's already noise free, then we can use that computing power in other parts of the image where it's still a bit noisy. So that is being worked on at the moment. So you see there's a lot of momentum going on in the performance area. Okay, now we will have a live demo soon. We will have this great workstation here from Cut Network. And the workstation is equipped with 2 Intel Xeon processors with 16 cores in total, which makes it 32 threads. We have 64 GB of main memory and 3 NVIDIA Quadro cards. Alright, so that's the presentation part of my talk here. Now we'll switch to the workstation and show you some scenes in live action. Okay, some small and lame disclaimer at the beginning. This is a development build that I just compiled this morning because we made a lot of improvements recently in the performance area, so excuse me if I get any crash or so, but I tested it and it should work fine. Alright, so I will just show you some scenes here. Correctly, okay. So let's start with a nice car model here. And first of all, I have to enable my GPUs. So I go to my user preferences here in Blender, and then I can select CUDA rendering. And as you can see, we have 3 Quadro K6000 graphics cards in it. And I will just choose all 3 of them to do the rendering. And then let's start the rendering process. It will take a few seconds to load everything into GPU memory, load the shaders and everything, and then it starts rendering already. So you see it is really interactive. I can move around, I get immediate feedback, and just after 1 second I have a nice image. It takes of course a few seconds to make a nice clean image without noise, but as you can see, you get an impression after 1 or 2 seconds, and then for the final frame you just keep it rendering for a minute or so, and then you have a nice noise-free image. So just that you get an idea, let's change the color maybe, make it nice red and go full screen, and so you can just see it rendering for a few seconds. So the whole thing here is really nice for the workflow, so you can tweak everything. I can move around geometry, I can change colors, I can change the shading, and it gives me an immediate result. When you have a big scene, like a production shot with some characters or so, it will take a bit to load everything into the memory, but once it is loaded, you can really quickly move around things and everything. So you see we rendered here 100 samples now in about 25 seconds, and it is really nice already here. So I can almost see no noise in this image now. Okay, so that's for that scene. Let's continue. So I have here another shot, which is a half interior shot. Some nice scene here with some. So we have an HDR image in the background for the lighting, and in the foreground here we have just that's a sort of simple scene, but you also see it converges very quickly. So after you rotate your camera, so you get a very fast response from the render engine, and you can start tweaking things. And I could take this object here, for example, and move that around. No. Maybe I should select that one. That one, okay. So you see now I've taken this object here and I've moved it around, and you get immediate feedback after the transformation here. All right. Okay, let's show you some other scenes here. That is also an interior here, and we'll update the shaders for a second. Then it should hopefully start rendering in a split second. Let's increase the preview samples here so it keeps rendering for a while. Let's go full screen. So there's an example of an architecture scene now, for example, which will take, of course, a bit because interiors are usually a bit more noisy because we have to do a lot more GI calculations and the rays are bouncing around a lot. But here, just after, now we have the calculation time, but it's like 20 seconds. Already we can get an impression about the scene and about the lighting in here. Yeah. Okay, I have some other scenes here to show you. For example, where's the quadbot here? That's a quadbot from the Tears of Steel Open Movie project. So we also get some very nice and fast feedback here. And then we could modify the scene here, like adding. Okay. On that one? Excellent. Okay. And then, of course, instead of rendering in the 3D viewport, you can then, of course, also render your final image. So just quickly check the settings here. Let's make that. So we have a square tile and render that. So that's basically the way you do the final rendering then. Cycles uses a tile-based approach, so it will render tile for tile and do the sampling. And that's what I talked about earlier on. So when you have the network rendering then, which is being worked on, you could just distribute those tiles, and those tiles would then be rendered on several machines, and you will have like 60 tiles or so on your screen, depending on how many machines you add to it. So that is a full HD frame here now. It's pretty fast. We have some rest noise here, but the quadbot itself is very nice already. All right. So I will also show you some CPU scenes here. The thing about GPUs is that it's of course very fast and everything, and it's a real hype these days. But in practice, you can still not port every algorithm onto the GPU. So as mentioned before, we already have subsurface scattering working on the GPU, although it is not enabled per default yet, because there are just some cards out there with some graphics driver that are just failing still. So that is a bit of a problem for us. Or has been the main problem in our development process, that even though it works on our machine, when we test the code and we render with GPU, it fails for someone out there with some specific GPU, and that's just really hard to debug. So we are always happy when we get a bug report to our bug tracking system where someone says, okay, I have this card and I have that GPU driver version and it doesn't work for me, and provides us with an example file so we can look into that, because there are just so many GPU configurations out there that it's a bit problematic to support them all out of the box immediately. Volumetric rendering is not working on the GPU yet at the moment. It worked before, but now since we added smoke rendering, that is not supported yet. So we will still need some time to port it onto the GPU. So there are some features that are CPU only at the moment. But on the other hand, on the right hand side, it's also nice because you can port some advanced algorithms onto the CPU. So you can not only do really stupid brute force path tracing on the CPU, you can also use more advanced algorithms to speed up the rendering rendering process, so that CPU rendering is not really slow after all. And I want to show you some characters here from the Caminandes short film, for example. We have our nice llama character here, which is in that file. Just quickly update the constraints here. Alright, so that is a llama character here, which the Caminandes team modeled for the Caminandes Open Movie film last year. And I will use CPU rendering here for that now. So I'll just quickly set the tile settings. And we're good to go. So that is one of the areas where we spent a lot of time recently improving the rendering performance. So we'll just build here now the scene, and now it already starts rendering. And you can see it is pretty fast here. We have here some 100,000 hairs with global illumination and everything. And that is being rendered now with the 32 threads we have in this system here from Cut Network. That is a final frame already, so there's no noise or anything in it, so you can basically could use that as a final frame already, and we render here in HD 720p resolution. So just keep that rendering for a few seconds. Our hair system supports several primitive types, so you can use curves, for example, to have really nice and smooth hair with subdivisions, or you can also use triangles and ribbons and stuff like that for your hairs. And we also have some great nodes, so you can basically tweak your material, so you have another shader on the tip of the hair strand and another one on the root, for example, so that is really flexible here in Cycles. Okay, so it's roughly about 1.5 minutes here of render time, and we're almost done with the rendering here. So that was a bit of a problem for us last year, the hair rendering, but we improved that greatly, mainly because of transparent shadow optimizations here and hair optimizations. Also, we did a lot of effort on the low-level part, so we optimize CPU rendering with SSE instructions, if someone knows about those kind of things. So the CPU basically can then optimize the scene and do many calculations in parallel here. Okay, so that is the Caminandes character, and since I've shown you that now, I would like to go back to my laptop quickly and show you the Caminandes short film that has been rendered entirely with Cycles. It's a very short one, just about 2.5 minutes. But for you to get an impression about the film project. So that is has been completely rendered with Cycles on CPU and GPU, I think, last year at the Blender Institute and on the render farm of Render Street. Alright, so that has been rendered completely with cycles last year and is a full animation short film. So you get an idea for the quality. Or this one is a bit more into the cartoony style, but it's a great example of how cycles can be used for an actual production shot. Okay, now we will stay at the laptop for a bit, and I want to give you short introduction to texture baking, which is something that the Live Filinto, one of our developers, worked on recently. And I will just give you a quick demo of the functionality here. This is still experimental. I think that's the wrong one. This one, yeah. Okay. So when we have something like this here, and we switch to cycles. Okay. So now, for example, when you have this cube here, and you have another object in the scene, like let's quickly add here a bottom, and now we want to bake the global illumination and everything that the cube is receiving. So I will just make a quick node setup here. So for the background plane, we just take a simple diffuse shader here, and then let's attach a noise texture, for example. And so we have here just a basic noise texture here, scale it a bit smaller. And now we have this cube. Now, this is of course rendered with global illumination now, so when you look closely, you see the color bleeding on the object. And now what we could do is that we bake out those information. So we just select our cube and go to the baking panel here. And I will make it external now, so we just save a texture out. So let's call it bake example. For example, I'll take a PNG frame. Alright, so I will just quickly, I think I UV unwrap my cube still. Okay, so I'll just press bake, and now I have here this bake example. And as you can see here closely, you have some, I hope you can see it, some nice, this GI contribution that is being calculated onto it. So you can of course increase the rendering samples, that is just the same parameter. So we'll make it like 30 and just bake it again. It takes a bit longer, but then we have again our image. The UV unwrapping here is of course wrong now, apologies for that, but just to give you a quick demo of how this works. And then this texture, it could be used in a game engine, for example, so you can have global illumination there, or you can just use it here in cycles to speed up the rendering. So you apply this texture back to the object, and then you set the renderer itself back to 0 bounces, so you don't have GI anymore, but you still have GI because you baked it before. So that's one way of speeding that up. And you can also not only render out the combined result, you can of course also just take the normals, for example. In this case we just have this one here, or you can take environment contributions, or just a direct pass or indirect pass, or the UVs, for example. So you can bake out all these different passes. And we already have the same system in place for 2 years or so for render passes. So, we also have render passes, which I mentioned before. So when you have a scene, that's a very just quick demo scene here, and you can output this image basically as all kinds of different layers. So we have our mist pass here, just make that smaller, and the backdrop larger. So you can have all these different channels here. That's the combined result again. And the direct contributions, the indirect, the ambient occlusion, the world, the emission shaders, and everything, and the glossy contributions and normals and everything, UVs, subsurface scattering. So we have render passes for all those kind of things, so you can tweak it afterwards and change it in compositing still. Alright. So another thing that I would like to show quickly is Cycles standalone. So Cycles has been written originally for Blender, but from the beginning it has been a standalone application. So it can be compiled without the Blender, without Blender on top. Okay. So what I have here now, I just run the Cycles standalone application, and I have some very basic scenes here. And this is now the Cycles standalone. So it's a very basic application we have. We have two possibilities of integration. So on the one hand, you can use an XML API if you like. So I will just stay here. Okay. Let's take a look here, for example, into that monkey file. So this is just a simple XML representation of the scene. So I'm not sure if you can see it on the projector. Yeah, but it's just simple plain XML, which we use at the moment for the scene. So you define your shaders with it and everything, and also the objects. And yeah, what we would like to add here still is to have some other ways of getting the objects in. So we will support OBJ, for example, and also later on, when Blender gets that as well, Alembic support. So you can load your geometry into Cycles with Alembic or OBJ then. And again, yeah, the application is very simple. It is standalone, but you can have like shortcuts here, or we have a basic interactive mode, so you can move around the scene a bit and rotate around and everything. Yeah, but that's mainly intended as a basic frame buffer for your scene. So then other projects or other 3D programs can utilize that, export the scene into the standalone application, and then just use that for rendering, or just keep it rendering in the background and pipe the image back to the host application. So if it's Cinema 4D or Maya or whatever, you could integrate it into that. And actually, if you're interested in those kind of things and you would like to see Cycles outside of Blender as well, then please get in contact with us. We are looking for people who want to integrate that into other programs. We already have some nice developers who offered their help and interest in porting it to Maya, for example. But we are still a bit in the process of discussing the API details with them. So we still, we already have an API here, XML, but you can also just directly load the data into our C data structures. Because Cycles is Apache 2.0 code, you can just link it with your commercial application, so you don't have to worry about those kind of things. And your host application can directly write into our render engine and directly pass the data via C and C++. So, but we are a bit looking for developers at the moment who want to get in contact with us and discuss the API topic with us, so we can make a nice proposal and have a polished and finished API then, so people can start to integrate it seriously into their applications. All right. Okay, there are two other things that I'd like to show. If we could switch back to the workstation, please. Okay, thanks. So, I mentioned OSL rendering before with volumetrics as well. So I would like to demo that quickly. So what we have here is a basic node setup with volumetric rendering. We have a material output, and then we have volume scattering and absorption, and the color. And in the beginning we have a very stupid and simple OSL script that I wrote midday today, which is just a few parameters. So we just take the shading points of the object here, pipe it through to sine and cosine functions. So that is then being used for the density input. And if I start rendering here now, you see that has been just a cube, but now we actually have some solid volumetrics with that. And you could use that for all kinds of crazy things, like you could have a cloud, for example, just entirely created with OSL. And let's take here this another one. So something like that. And you can then basically use that to create complex volumetric objects and volumetric shaders here. And again, we are the only engine on the public market that has OSL support and volumetric shader support here. So the other engines don't support it yet. But we have it in Cycles already, so you can, instead of only having the surface shaders for procedural textures, for example, for what it's being used already a lot, but now you can also do volumetric shaders with that and create clouds or any other effect, or volumetric fog and lighting and everything, and use OSL to really get started with that and do a lot of great things here. And I still have one file to show to you, and that is something to just show you that we not only work on performance optimizations, but also on algorithmic optimizations. So I have one scene here, which has a lot of point lights here. And multi-light sampling is something that is a bit difficult for Path Tracer, because basically for every bounce, for every sample here, we just sample one individual lamp. And as you can see, that is pretty noisy. But now we invented an algorithm here and built into one of our two integrators. So we have plain path tracing and another one which we call branch path tracing. And the branch path tracing gives you control over your samples. So you can, instead of just saying, if I switch back with path tracing, you can just say, okay, I want to render the image uniformly with 100 samples, for example. But when you use the branch path tracing one, you can say, okay, I want to spend more samples on the diffuse shaders or more samples on the subsurface materials. So if you have a scene which is pretty quickly noise-free in your diffuse parts, but you still have some glass in there or some mirrors which still needs a bit more of time, you can just say, okay, I increase the glossy samples here, then I get a better result for the glossy shaders here. But now we have added multi-light sampling here. So we have two checkboxes here which are enabled per default, but there are some trade-offs. So sometimes it's maybe if you need a lot of anti-aliasing samples anyways, you might want to keep that disabled for performance reasons. But you see, this is very noisy here. But now I add enable multi-light sampling for the direct light. So let's look at the bottom here. Just enable that, and it's immediately noise-free. And if we do the same for the indirect lights, so if you look here at this sphere, for example, the noise we get here or here on the monkey, or also here on the glossy sphere, and I do the same multi-light sampling for the indirect GI bounces now, you see we also get a very clean result very fast. So those are some things which we work on as well in terms of algorithmic optimizations to make everything faster and better. So those kind of algorithms, those kind of things are also kind of things that we work on. So I still have 10 minutes. I still want still some time for questions, of course. So there's one last thing that I'd like to show you quickly, and that is smoke rendering. So that is something that we added just end of March. So Brecht von Lommel added that a few weeks ago. Let's just take our quick smoke operator here. So we have a very simple scene here, and we use that as our smoke emitter. And then let's just, bring it inside the domain. Let's just calculate the smoke here for a second, or let me quickly change to smoke and fire. So we have fire and smoke here, and increase the resolution a bit, so we have some better resolution here of the smoke simulation. Okay, so we have some very basic and fast smoke here. You can of course crank it up and use high resolution smoke here as well, but that would take too long to bake the physics now, so just skip that. Maybe I should just quickly bake that. Just quickly bake the simulation. Then I'll show you a basic smoke and fire setup for cycles, which you can use to have smoke. So now we have here our nice smoke flow. And then let's go to the cycles materials and material nodes here. Let's switch to cycles first. Okay, so we have two outputs here. So you can either use surface or volume shaders or both. For example, if you have like a glass surface and still want to have some volumetric absorption into it, you can use both. In this case, I will just add an edge shader here to combine volume scattering, which scatters the light inside of our volume medium, and add absorption as well. So that's basically a basic setup. And now all we need is an attribute node here, and we take for one the smoke here. Oh no, not smoke, density. Okay. And we use that for our density. And I can still add a math node in between, so we can change the strength of the actual density. So let's render that. So you can barely see anything. That's why I added that math node, so we can increase the density here, make it thicker. And then I can also go ahead and add another attribute node here. This time I want the flame information that we have, and let's add an emission shader. Combine that together, so we have here our smoke shader, and so we have here our smoke component, and here in the bottom we have our fire component. So I can take a color ramp here to modify that, and yeah. Oh, something is wrong here. I should take the factor. I'm missing something, I guess, here at the moment. It's not taking the density into account. No, it's not a color, it's not correctly taking the... I think it's flame. Pretty sure about that. But something is wrong now. Probably it's something completely obvious here, which I'm missing at the moment, but... So I mean, I could just go ahead and use another volume shader with that. Plug it into the density output. But yeah, I would need to change the color. So sorry again, something is wrong here at the moment. I didn't check that earlier, so it doesn't take the density into account properly. But that's basically a basic setup you would need for smoke. Although we want to add a convenient node still for that, so we will have a dedicated smoke fire node. So you just add one node. You can output that directly to the material output. So yeah, again, that's has just been added end of March. So we will have a dedicated node in the end. So yeah. But yeah. All right, so that leaves me still about 5 minutes for questions. So thanks everyone, and I hope you learned something interesting and you will give cycles a chance and test it out. Download it from blender.org with Blender. And again, if you're interested in seeing cycles outside of Blender, just talk to me or mail us on a mailing list or so, and we can figure something out. Thank you. Okay, are there any questions? Yes, please.
How do you author the materials? Is that OSL that you're writing, basically the node form?
Yes. So basically all our nodes that we have are just a user interface at first, and then the background code is actually written in OSL. and the other one is another shading system we have that we use for the GPU. So all the nodes we have are being written or have an underlying code in OSL, and the other one in the other shading system that we have for GPU, yes. So every node is a OSL shader, and you can check the OSL shaders themselves as well and change that, yes.
Convert one to the other, or that's a manual process?
It converts that. I mean, you can, if you enable OSL, every node will be OSL, and then in addition you can have the script node to add your own shaders to it. So your entire shading network is then OSL and calculated by the OSL engine. Yes. Yes, please.
Will there be more convenient modes to add transparency from transparent PNGs, for example, to any BDSF shader or something?
Mm-hmm.
At the moment, it's like combining diffuse or whatever shader with a transparent one,
Mm-hmm.
adding the transparent information to the image.
Yeah.
That's a little bit
Yeah, I agree with that. We are working on node groups at the moment. So we want I mean, for those of you who know Blender, you know when you start Blender, Blender internal is still our default engine. So you have to click one button to jump to cycles. And the reason for that is that before we make cycles default, we want to work a bit on the workflow still and add some convenient nodes. So we will basically bundle some finished nodes for like a standard surface, a standard volume material, some production tricks for faster acoustics and stuff like that. So yes, that will be addressed. Yep. Okay. Yeah.
Well, with regard to inverted loading of geometry, are there any plans of implementing inverted loading of geometry both in Blender and in cycles, especially when Alembic support comes?
Yeah, that's definitely something that is planned. So we worked a bit on FBX the past few weeks, but Alembic is definitely on the roadmap, and we want to use that both for geometry import and export, but also as a cache for our shading systems. So at the moment, our smoke simulation, for example, has a point cache, as we call it, which is a system to store all the information in. But we also want to use Alembic for that later on. So we want to make everything Alembic based there and use that format to exchange geometry and also to use it as loading format into cycles, yes. Yes.
Are there plans to implement shadow catcher?
Shadow catcher, yeah, that's something that comes up a lot. Yes, it would be nice to add, but there's, as far as I know, no easy way to do that realistically in a path tracer. The thing is, for a path tracer, there is no real concept of shadow. Everything is just a ray that is bouncing around, and there is no real concept of shadow. So everything you have is global illumination, basically. So we have shadow passes and stuff like that, but having a shadow catcher, I guess it is possible. Other render engines have it too, but it is not clear how to do it in an accurate way. So we have to see about that. But yeah, it would be nice for compositing. Yeah, I know. We should add it, yes, but it's just one item of on our very big to-do list. So maybe if we can very quickly jump back to the laptop. So that is our to-do list that we have at the moment. So you see we have still a lot of smaller features, UI improvements, performance, although that is not really everything. We have an entire paragraph, an entire site here for optimizations. So that is also something that I mentioned. We will really focus on optimizations this year. So there are several approaches what we can improve still. So VVH, ray tracing, triangles, hair rendering, shaders, the shading system itself, the sampling. So those are a lot of great ideas which you want to work on. And if I look at my work in progress release logs for the next upcoming Blender release, you see the big two features that have been added recently: deformation, motion blur, and smoke and fire rendering. And you also see here some optimizations already. So here we made transparent shadows 30 to 50% faster. We made hair rendering faster and CPU, GPU optimization. So we're working on that at the moment. Yeah. Yes? Okay. Mm-hmm. Mm-hmm. Okay. Do you talk specifically about cycles or Blender in general? Okay. So you can always, we have a mailing list called BF Funboard, which is used for, well, it's I guess a place for where people can submit feature requests, and you can also just come into IRC and talk to us directly. So if you go to blender.org, you will find some information there about get involved here, and you can find here some links and everything about the development and how you can get in contact with us here, contacting developers. So we have here some information here about our mailing lists for the specific project. So we have a specific mailing list for cycles where you can mail to, for example, generic Blender mailing lists. We have the IRC chat and weekly meetings and everything. So you can get in contact with us here. The reason why we don't have a general place to put infos in is that the community is huge and there are so many features that people want, and I fully understand that, but we just don't have enough developers to implement everything. So it's not really beneficial for us to have like a list with 1,000 feature requests and we cannot tackle them in our lifetimes. So what we have is basically we have module owners for specific modules in Blender, like we have module teams for cycles, for motion tracking, for modeling, and those teams basically decide what will be worked on next. So you can approach those people. You can find the information here as well in the contact information, and then these teams decide what will be worked on next based on feedback, but also based on some things from our own to-do list. So just get in contact with us on the mailing list or so, and then we can see if that's a feasible project that we can add to our to-do list. Yeah. You mean instead of UV unwrapping? Oh. Mm-hmm. Okay. Mm-hmm. I think you have. I think there's a node setup for that if you don't want repeated textures, or if you. I mean, if you just assign a texture to cycles, it will of course just have it once. Okay. Mm-hmm. Mm-hmm. If you have an UV image. Mm-hmm. Okay. Yeah, we have a checkbox in Blender internal. That's right, and yeah, I mean, if you do a proper UV unwrapping with the texture, then it shouldn't repeat. I mean. Mm-hmm. Yeah. If your UV unwrapping is fine, then of course you will get what you assign to your face. So yeah. But we have some options also. For example, we in Blender internal we had like automatic mode, so you can immediately have a sphere projection or so, stuff like that. We can still improve the workflow there a bit and add more easy buttons to do it immediately. To instead of UV unwrapping, you already immediately get a box unwrapping or a sphere projection or something like that. Yeah. Mm. Mm-hmm. Okay. Maybe you can show me that afterwards. Maybe there's something that is wrong, or maybe you missed some step or so. Okay. Okay. Yes. Mm-hmm. Mm-hmm. So on Windows we use Visual Studio 2008 at the moment, but we are jumping to 2013 at the moment. On Linux we use GCC, and on Mac we use CLang. Clang. Yeah. Mm-hmm. Mm-hmm. Okay. Okay. So we had a Caminandes movie that was mostly rendered on CPU, I think. But we will have an upcoming project which is still in the pipeline, so we're not sure. We're collecting funding at the moment, but the plan is to have a full feature-length animation film there. Not everything there will be cycled, so we'll also use some non-photorealistic rendering, but half of the film, like 40 or 50 minutes, will be cycles. And I guess the main idea at the moment is to use CPU. That's not clear yet because the Blender we have a a render farm in the Blender Institute with 60 nodes, Core i7 that is CPU at the moment, and I mean from the technology standpoint of view, we have everything working on the GPU except volumetric rendering. That is a bit of a hassle still, but the rest is working. So it just depends on VRAM size, I guess, on the GPUs, and if we I mean we always get sponsoring of course as well, so it will be seen if we will use CPU or GPU. We can, of course, use both and combine it later on. Yeah, it's not clear. It worked already. We had it working, but it broke since we added smoke rendering. So the problem about GPU is that we have a mega kernel. So we don't have split code parts. We do everything in one mega kernel. And every time you add a big feature, it's not so much the problem of getting it working. We have everything working, also volumetrics. But every time you add something new, it slows down the kernel. So even though you don't use volumetrics in your scene, you will have like 10% slower render times. Sorry? Yes. Sorry? Yes. Yes. So our GPU kernel is about 1.5 megabyte already, and I'm not sure if it's the size itself or just the complexity of the kernel. And the NVIDIA toolkit, the CUDA compiler, gets better every version, and we also made some tests with the latest release. It optimizes the code better, but it's still, I mean, NVIDIA says it itself that a mega kernel is suboptimal for GPUs, so their optics framework is also doing some smaller kernels and split that up, and that is something we might look into one day because we have also severe problems on AMD hardware. So we have OpenCL support, and our kernel runs fine on CPUs or NVIDIA GPUs, but on AMD it either doesn't compile, it crashes, it's a bit of a hassle. But I heard from other companies also here at FMX they have problems with AMD as well, so maybe it's just their compiler a bit. But yeah, it's a constant problem we face, and GPUs are still so young, and it's nice to have this technology, but yeah, we will still see how this technology evolves and if it will be the thing that everyone hopes it will be, or if it will be just this temporary thing and we will still render on CPU in 20 years, I don't know. Yep. Yes?
Since like it's does support CPU rendering via CUDA or APIs like OCL,
Mm-hmm.
would there be the possibility to add support for async devices?
Mm-hmm.
Because that would be awesome, just like plugging in multiple things into your computer
Mm-hmm.
and speed up running 10 times or so.
Yeah. Yeah, it would be something that we could add later on. So we also work on the network rendering, which will then utilize CPU and GPU at the same time. So that is something that we already have working with OpenCL. So you can combine CPU and GPU and use it together. But we're still fighting a bit with load balancing between CPU and GPU. So that's a bit of a problem. But yeah, in principle, it's possible. But yeah, long way to go still. Yeah. Okay. Then thanks again, everyone, and have a nice evening. Thanks.